Great, thank you. Welcome everybody. Today we'll be talking about the latest updates from Microsoft's AI and ML technologies. My name is Ben Dunmeyer. I'm a data analytics and BI consultant with Thorogood, based in Philadelphia in the US, and joined today by my colleague Deb Lee, and we'll be taking you through this session. Very quickly looking at the agenda, we'll say a bit about Thorogood and then kind of a number of things that we want to get through today. I'll give a kind of rapid fire recap of some of the latest updates and enhancements to the tools, and then I'll do a demo of cognitive services, which will be fun. And then Deb will come in and she'll talk about Azure ML, Databricks with a bit of a demo, and then wrap up with some of her thoughts in the field as kind of one of the firm's experts in this space. So quickly on Thorogood, we are an independent global professional services firm specializing in business intelligence analytics, strategies, solutions, and services, focusing on our customers. We're a global organization with offices in Philadelphia, Boston, London, Bangalore, Singapore, and Sao Paulo. And we do offer a full range of BI and analytics services, including strategy and roadmaps, design and implementation, training, and support, among others. We're an independent firm, meaning we don't work with a single technology, but partner and work with a lot and most of the key players in the market in order to give our clients the appropriate solution to fit their needs. Today, we'll be leaning towards Microsoft and Databricks, but as kind of in addition to that, staying on the cusp of these industry leaders and as well as niche players in the AI and ML space. It does help us to maintain a well-rounded perspective, keep track of first movers, and ultimately help our customers, not just in AI and ML, but across all aspects of data science, data engineering, data visualization, data strategy. A few bits here on our Microsoft partnerships. So I've been a Microsoft Gold partner for a number of years, and like today and beyond that with some of our other trainings that we run, offer various different educational webinars and trainings, then are part of a number of different programs with Microsoft that kind of keep us close to some of the technology advancements and also allow us to provide feedback directly to them. So jumping into a run through of the tools, to open it up, I think there's a ton of buzzwords and interesting things out there today. And we're starting to see investment in this AI space, and we've kind of seen it for years across different firms. So it's more and more other industries buying in and exploring what's possible. So over on the left-hand side, some of the stuff that's a bit more kind of happening right now. So things like ML ops and productionization, whether organizations are productionizing their models or developing frameworks and approaches to do it at scale. We're seeing a ton of that and helping a number of customers with it. Something Deb will talk about, but white box or Glassbox models, so kind of automated modeling that allows us to seed some approaches or get a starting point, in addition to things like low code and no code, which we're seeing kind of take off with some of Microsoft's and other tools. Then over on the right, getting things that are a bit more nascent and kind of on the bleeding edge, so spatial sentiment image recognition analyses, which aren't necessarily that new, but kind of getting more kind of effective and efficient. AI for cybersecurity, so very popular, particularly with a lot of the different things that have been in the news lately with different organizations having issues with data security and something important to us. And then something like Edge AI, which I'll talk about a new Azure tool around it very briefly, but that's kind of really on the cutting edge of using massive amounts of data in real time to kind of control decisions. So there's a lot out there, a lot of interesting stuff, and what we hope to do is kind of see how we're applying it, how it can be applied, and how you can get started. So Azure Machine Learning, Microsoft's kind of flagship machine learning. Some updated features, though, that I think really Microsoft's now pushing to get Azure ML to a space where it's fully ready to use. They kind of released it over the past year or so, and now are working on the operational side of it, getting it performant, having all the bells and whistles. So they got a product there. Now they're, I think, really just adding on the top of it. So an updated CLI, so command line interface, and Deb will talk in a bit more detail, but it's just more functionality to automatically or with code manage compute, whether that's scaling up or down, scaling out or in, or just general monitoring. As we see the push towards infrastructure as code, the ability to define pipelines in YAML context, and able to do it programmatically through a CLI, some pretty valuable stuff that's pushing us into the operational side of things. Obviously, something that might not be apparent to end business users or teams that are using machine learning models, what they'll greatly appreciate is enhancements to endpoints deployment. So whether it's real time or batch, whether it's hosted as part of a huge cluster, distributed in different regions, so many different possibilities depending on the situation. But the more we're able to do to be kind of performance, getting high response rate, getting high reliability, Microsoft's investments into that have really helped us to take things that are built and working well and then run them at scale, in the face of business and with the business. And like I mentioned, certainly pushes on SDKs and the different interfaces that are used to manage Azure ML. And I think we also see Microsoft looking towards integrations. So with Synapse, Power BI, you can see the list there. And then even open source things like ML frameworks with TensorFlow and Keras. We can see Microsoft now looking to see how this fits in with other tools that people are using. Next one on here, cognitive services. So very can describe it, whereas Azure Machine Learning is kind of ML as a service, we might think of cognitive services as AI as a service. So in some cases, kind of black box models that we're able to score information from and use a number of different features and services. Recent updates, particularly around text analytics. So with the times, enhancements around health, so identifying different health terminology, taxonomies, more efficiencies in document translation, and then always adding new languages. Fairly new over the past couple of months has been a form recognizer. So I think something Deb and I hear a lot of is we have all these PDF files or non-columnar, well, they might be columnar, but non kind of CSV or Parquet type files that we need to extract data from. Form recognizer is kind of getting to that point where it's able to extract data into a format that we can then use with data tools. So it's pretty interesting. And another one, a bit niche here, but with cognitive services anomaly detection capabilities, they've added multivariate possibilities. So certainly we know with the complexities of the sorts of things that we're trying to detect anomalies in, whether it's manufacturing sites or I think the example we'll use in the documentation or an engine with so many different components that you want to test for and understand their impact on results that you do or don't want to have happen. So introducing that complexity, I think it's the overall theme with Azure. They got a foundation. Now they're adding in complexity, adding in features to it. Databricks, and I'll probably be quick about Databricks because Deb's going to jump into it. I don't want to steal all her thunder. At the Spark Summit a couple of months ago, Databricks announced their machine learning interface to go along with their existing notebook-based or data science and data engineering notebook-based interface. And really, it's a big step, a big move. I think a competition, but it's introducing a number of interesting features and capabilities, and it's allowing us to consider Databricks as a tool to manage the full lifecycle development, operations monitoring of machine learning and AI models. They've also released their feature store, which I think we're seeing it as a technology becoming a bit more relevant and being talked about. So I think it's something to keep an eye on and do some research on. But really, I think it almost seems to me kind of like a data lake where you're storing data, but instead of data, it's very specific measures or definitions or features. I think the ultimate challenge with it will be how are we able to define things that are shared amongst our entire organization, or do we need to segment and silo things? But it's getting to that point where we're doing ML and AI at scale on top of foundationally good data, which is, we can't lose sight of having a good, solid data foundation. And then AutoML, which I referenced, the white box or Glassbox models. Deb will do a demo of this, so I'll leave it to her. But another way that we're kind of getting started with. The last one here, probably the most nascent, applied AI services in Azure Percept Studio. Applied AI services is kind of like solution accelerator. So they're taking cognitive services, task management sort of technology, and Azure machine learning and putting together kind of products and offering those up. So you can see some of the examples there. So this might be a case if you have a specific need. It might be an option to explore more of an out of the box product as opposed to building it yourself. And Percept Studio, pretty brand new, still in preview, but Microsoft's kind of first stab into, not sorry, first stab, but Azure offering into Edge AI. So I think pretty limited features to start with, but thinking about the integration of kind of real-time or massive amounts of streaming data or Internet of Things source data, and then building on top of it the sorts of recognition, whether it's, you can see vision and speech, there's the first couple, but how are we starting to build out this sort of Edge AI models, which is pretty interesting and one that haven't done much exploration of. So let me talk a little bit more about cognitive services, and then Deb will jump in with a few of the other tools. So I mentioned cognitive services. It has a number of different services within it, and you can see the list there. And generally, the sorts of things you might expect, whether it's text, image recognition, or audio. And really, generally, how it works is there's not necessarily for a few of these, there's a user interface, but generally, this is kind of AI as a service where Microsoft has built and sophisticated these models in the background and kind of their property, and then enable us as users to interact with the APIs that are sitting kind of between the models and us and sending them information. So we're able to send content, whether it's audio files or image files or maps or whatever, into the API that we want to receive a response in return. So I'll kind of draw that here. Whether we're, like I said, all the different sorts of content that's aligned with the different services, and then the inbuilt APIs will give us a response based on what we're asking for. Often, though, we want to extend this a little bit to leverage the intelligence and capabilities of these services, but on the sort of stuff that's relevant to us. So there's obviously some inbuilt and out of the box things, but if we want to do something specific for our organization, we might need to train that computer vision, which is the demo that I'm going to show. We might need to train that computer vision on our images or our files and tag them as appropriate. And for us, we did something fun with cats and dogs, but you can kind of think about the capabilities here. The possibilities are really endless, but we're able to send images or audio files or whatever to cognitive services for the appropriate API, tag, and then the kind of trained models will then be available for prediction. So we can then have, whether it's an application or just an end user, be able to score their own images after we've kind of trained whatever model it is. So that's how we're kind of bringing it to the enterprise. So let me demo it because I think it's a pretty interesting tool. So here I just have Azure up quickly to show this. So we kind of have a cognitive services account, and you can see the different options here. If we go to one of these, it's not going to bring us to necessarily a UI interface, but largely to documentation where you can see and understand how to interact with the APIs with lots of different languages and give them there. So this is how we can kind of start building. Like I mentioned, we can interact with APIs. So what we built is a relatively simple Databricks notebook that will interact with some existing Python libraries. So great that these are built for cognitive services and we're using custom vision. But we are able to collect a data set. So we just downloaded, I think, an online cats and dogs data set, stored it on blob or data lake storage. And from here, we're able to create a new experiment, or I think they call it a model or project, a project in cognitive services. We're able to take our data and tag it how we want to tag it. So again, we just did cats and dogs, but we could possibilities are limitless. And then some logic to send those images and train them on the custom vision or computer vision model. So here we've effectively trained the model ourselves, created our own model using the cognitive service capabilities, and then we're able to interact with it. So I'll close this up with some initial thoughts, but why don't we take a look at it? And we can be fun, and we can train on, predict based on some images of Deb and my pets. So we'll quickly do that. We'll do my cat Tank first. So not a great image, kind of washed out and not good lighting, but still 85% likelihood that it's a cat. So got that one right. We'll take a look at Nala, Deb's husky, and pretty high probability there with additional things in the background. So stuff in the foreground, other things it's able to identify the central image. Then one more, just because it's fun, a bit of a better image, a starker background, and as close as you can get to 100%. But pretty, it's cool, it's interesting, and it's fun to look at. But yeah, I think it's really interesting with relatively kind of small effort to set this up. And the training set here is about 17,000 images, a pretty reliable model, at least to start. And there's lots we can go into here. We'll go to all the different tabs here, but we can see how it's performing based on the training set we gave us. If our training set's very poor, we might see different results here. And if I just center this back, of course, we love our pets, but how can we see this envisioned in enterprise organizations? I think Deb and I particularly work in the CPG space, looking at circulars where there's hundreds and hundreds of images and different promotions. If we can get that leg up to know what our competitors are promoting when they're promoting, that's pretty powerful. Joining that back into our enterprise data. I think something Deb's super passionate and interesting about, I'm sure she'll talk about. But an example where, coming from a Microsoft case study, where they've recognized people and usage of rooms to control HVAC and lighting and those sorts of things to be more energy efficient. A few others I think commonly we'll see, and now analyzing claims documents and financial documents to make them readable, so things that are coming in PDFs. translation for chatbots, and then something similar to sustainability, but on the ESG front, looking at spatial analysis, maybe for deforestation or pollution or changes in our environments, and being able to turn that into quantifiable measures to measure sustainability or report on it. So all that stuff's super interesting. I think we keep saying it's on the bleeding edge, but it's kind of where we are right now. But taking up my time, I'll hand it over to Deb, and she'll run through some of the other tools. So Deb, please take it from here.
So from an Azure Machine Learning perspective, just to recap, it's really a cloud service for accelerating and managing your ML projects. From a lifecycle perspective, there is a notebook interface, so more of a code-first approach to develop and build and deploy models, but then there's also an automated ML offering to really help you cut down on those repetitive, potentially time-consuming tasks in that initial model sort of scoping out phase. And then there's also that sort of in between with the designer, the drag and drop interface. Thought it would be helpful to do a bit of a recap on some of the common frameworks and integrations that Azure ML offers. So, data scientists can use models that they've created in other common Python frameworks, right? Like PyTorch, TensorFlow, scikit-learn, XGBoost, R, .NET are both supported. And then there are a variety of development tools that are available to really suit your needs depending on what you'd want to do. It also offers support for sort of those deep learning applications as well, using GPUs. So things like PyTorch, TensorFlow, distributed multi-node use cases. One thing I wanted to call out here is that I'm going to cover some, I think, features that are really indicative of sort of where the direction the tool is going, what we're seeing, but they're constantly releasing new features and updates. I wouldn't be able to get through this entire list in the time that we have today. So it is worth checking back, and they're quite receptive to sort of feedback on the tool if you are using it. We've had a couple of projects where we fed back on parameters that weren't working directly back to Microsoft, and we've actually since seen some of those issues have actually been resolved very quickly. So the first thing I'm going to talk about are endpoints and deployments. So an endpoint is an HTTPS endpoint, right? So the client can call that to receive effectively the scoring output of your pre-trained model. So it's going to provide authentication, that key and token, SSL termination, and traffic allocation between deployments. And a deployment is really a set of compute resources that are hosting the model, right, that perform the inferencing. So it'll have the model details like the code, the model, the environment, your compute resource and scale settings, and maybe more advanced settings. A single endpoint can contain multiple deployments. And endpoints and deployments are independent ARM resources that will appear in the Azure portal. And in terms of how you're thinking about doing your deployments, there are both online and batch endpoints available. These are really in public preview right now, so they're available for you to start using. But I would say if you're testing them, please send feedback on them. And then for the native blue-green deployments, I also think it's worth calling out that since a single endpoint can have multiple deployments, an online endpoint can perform load balancing to allocate sort of any percentage of your traffic to each deployment. So thinking about performing safe rollout of your blue-green deployments, right? And then the integration with application insights, I think, is also worth calling out. So maybe you're used to using the Kubernetes online endpoints. The Azure ML managed online endpoints will have out-of-the-box integration with Azure Logs and Azure Metrics. So that'll help you just stay on top of your overall sort of system and model health more easily without having to write more custom logging and exception handling into custom tools. Another announcement that came out past couple of months was the sort of 2.0 command line interface. So the ML extension to the Azure command line interface. So it's really an improved interface for Azure ML users. It's going to enable you to train and deploy models from that command line, right? So features that'll really help you accelerate that scale up from maybe a data science POC to something that's actually able to be stable in production. You can, run distributed training jobs on GPU compute. You can do automatic sweeping, hyperparameter tuning to help improve your results. And then you can also monitor your jobs, right, and submit different types of jobs, which I'll cover in the next one. Really a job in Azure ML, it enables you to prepare and train an ML model, right? So what are you running, your code, how do you run it, and where do you run it? So I thought it would be good to also just call out what's really available right now. So I think what's kind of exciting is that there are a bunch of sort of templates that have already been released and are constantly being improved and rolled out. They're available on GitHub right now to really help people accelerate and get started quickly with these APIs. So ones for training, deploying, creating a workspace, creating or updating your jobs, right? And then updating those online endpoints. These are all available out of the box, and there's a fair amount of documentation available on them. So pretty accessible if you want to get started quickly. And then in terms of sort of other new features that I think are worth calling out as the sort of Azure Machine Learning extension for Visual Studio Code. So it's actually been revamped for that 2.0 command line interface compatibility. So features like completions and diagnostics for your YAML-based specification files. You can continue to manage your resources directly from within the editor and create new ones with those starting templates. The Visual Studio Code is really just an interface that's going to let you sort of manage your resources, like your experiments, your VMs, develop locally using remote compute, train models, debug them, maybe you have schema-based language support, right? And as always, for anything that's in public preview, or you're curious, how do I get started with this? I would say just reach out to us. We're happy to provide any documentation or support. That was a bit on Azure Machine Learning. I'm going to switch gears now and also talk a bit around Databricks. So I thought it would be helpful to sort of go back and recap some of the new features that have also been released into public preview since they were announced back in May at the Data and AI Summit. So the first one are the feature stores. So a feature store's primary purpose is to connect your data to your model deployment. Databricks' feature store is really a centralized repository feature. So it's going to enable sharing of those features and allow other people to maybe discover things that have already been created across the organization. And also it's going to help you sort of maintain better consistency across those features that people are using. It's really only available on Databricks runtime for machine learning. You can access it through both notebooks and jobs. And I would say the sort of compelling offering, or I think what's most exciting about it, is that it's really tightly integrated with the popular open source frameworks. So Delta Lake and MLflow, all within a given Databricks resource. What does that mean? You get to take you don't have to do sort of any extra work to get the feature store functionality working with tools like Delta and MLflow that you're probably already used to working with if you're working in Databricks to build and deploy models. The second sort of public preview announcement feature for Databricks that I thought would be good to touch on are the Delta Live tables. These are also in public preview right now. And the Delta Live tables are really a framework for building reliable, maintainable, and testable data processing pipelines. So you define the transformations to perform on your data, and Delta Live tables manages the task orchestration, the cluster management, monitoring data quality, and error handling. So instead of defining your data pipelines using sort of a separate series of Spark tasks, Delta Live tables will manage how your data is transformed based on the target schema you define for all those processing steps. Two more features worth calling out that just got pushed into public preview: job details. So really streamline your management of settings for Databricks jobs. I know this is, Ben and I have both wished that these settings were available on projects in the past. So if you go to the job details side panel in the jobs UI, now you can update settings like job schedule, cluster settings, maximum concurrent runs, alerts. And then the day before that, Databricks SQL got pushed to public preview. So it should be getting rolled out to all the available workspaces. And it's really an intuitive environment for running ad hoc queries, creating dashboards, maybe querying against your data that's already being stored in your data lake. So yeah, reach out if you're curious or looking to get started with any of those. And then I'm going to talk a bit around AutoML. So this was sort of one of the key features that was announced back in May by Databricks. And so the Databricks AutoML is really meant to help you automatically apply ML learning. So maybe things that take a lot of time from a data scientist to a prepped data set. It's going to prepare the data for training, perform record sets of trials, creating, tuning, and evaluating multiple models. So it's going to display the results, provide you with sort of a couple of Python notebooks so that you can really understand what did sort of the AutoML process go through to get to the recommended best model that it created, and generate that code for you as a starting point, which is pretty useful, I think, if you're trying to get started with some experimentation. So to use the AutoML functionality in the Databricks workspace, you'll want to make sure that you're in the machine learning workspace to get started. You could access it through this button here where Start AutoML. You could also go to Experiments and click on Create AutoML Experiment. You need a cluster running in order to start an experiment because you need some compute. It needs to also sort of meet the criteria for AutoML. You can define the problem type. So is it classification, regression, or time series? Browse, right? So let's say I do, I actually have a use case. I'm interested really just to understand, is it possible to create a decent classification model? In this case, I have different levels of gene expression of RNA in various cells, and I'm trying to categorize the various phenotypes of those cells based off of their expression, something that I was doing, manually labeling before. So you can select your data set. Nice, you can see the schema of it. You can specify, I'm trying to predict the phenotype of these cells. You can set up some advanced configurations. So what types of metrics do you want to prioritize, right? Specify how long it should be running, how many trials should it try before it quits, and then is there some sort of location where you want to store stuff rather than the default one? And then you start the experiment. I ran the experiment yesterday because we don't have an hour to wait. So you can see here the ML Flow UI interface, everything here is built for me. I can quickly see the best model was random forest. I can see the metrics logged for it, okay, from sklearn. All right, but I want to actually see what did the confusion matrix look like, right? So it's going to generate some code. I can get the environment details. I can get the pickle file for the model, and I can actually start to see it automatically logged some artifacts for me. So I can really see, do I think this model is even going to be valuable, right? My validation, my training confusion matrices. It'll also generate 2 notebooks here. So it'll generate a data exploration notebook and a model training notebook. The data exploration notebook, pretty nice, I would say. It's very well clearly commented, and runs this sort of profiling report on your training data, so you can start to see, does this data set even make sense for me to try to train something on? And then you can also get to the model itself. So this was the random forest model. I can see the pre-processing steps, the feature standardization, training test splits, and then the actual classification and the hyperparameters that were used to get to that best model. So I could take this notebook, I could take this model and deploy it. I could use it as a starting point, maybe do my own stuff. But all the code here is now generated and available for me to actually start playing with, which I think is pretty neat. The only thing I will say, in my experience is playing around with some of the AutoML capabilities, is that right now it only runs on a single node. So if you do have a massive training data set, it's going to still error out on that node. You'll probably need to move towards something that's a bit more Spark native in terms of the model training that lets you use more nodes available in the cluster. But I do think AutoML will solve some key pain points around being able to verify whether or not a data set is good enough for modeling. And then also, can we generate some kind of baseline, right, that we know at least this is what we should be trying to beat for what we're going to build. And then I think the classic Glassbox problem. So, many of our customers will say a sort of a key concern for them is that, for solutions where, it seems too good to be true, right? And if it's a black box and they can't understand what the model's doing, the fact that this is going to generate all the code for you and you can understand what's happening is really what they mean by glass box approach. So I know exactly what transformations were applied to get to the model that's giving me that accuracy and that score. Quite powerful. Wrap up now. I'm going to just comment a bit on sort of what we're seeing happening right now. A lot of companies are investing in AI across the board. I think the latest estimate I saw was 204 billion by 2025. But a lot of companies are also saying that they're not really seeing, significant financial benefits. So I think 11% compared to 71% saying they think AI will change their business. And I think what's the sort of key message or takeaway here is that, and I like sort of Andrew Ng's take on it. So I think he's leader in the AI field, really pioneer here, is that if you're going to get started tomorrow, his point is just jump in. Like, it's already sort of disrupting and causing so many shifts in the industry. So if you're not already making pretty aggressive and smart investments in this area, now is the time to do so. The technology is there, more and more data is being collected. Now is the time to start experimenting and figuring out, where can this really add a lot of value for our organization. We have a number of services that we provide in this area, and more than this, honestly, than what's just on the list. So if there's really anything that you're interested, I would say just shoot me or Ben an email. I'd be more than happy to talk your ear off about any of these types of topics. And thank you very much for coming to our webinar. That's all we have for today.